So in this example, we're asked to sketch an angle measuring 900 degrees in standard position. And then we're going to find a point on the terminal side and use that to find the values of sine of 900 degrees, secant of 900 degrees, and cotangent of 900 degrees. So the first thing we need to do in order to draw this thing in standard position, we'd like to know what quadrant it lies in. 900 degrees, though, is bigger than angles we're familiar with. So, 360 degrees corresponds to a full rotation. All the way around here is 360 degrees. 900 degrees is clearly more than that. So the way that we can find a coterminal angle that's easier for us to draw is to subtract 360 degrees. So the idea is, let me just draw randomly. Let's suppose this isn't the case, but suppose that our 900 degree angle terminates in quadrant 3. Then when we subtract, so 900 degrees, that's more than a full rotation. We've gone around and around, landed, let's say here, even though that's not the right spot, but I just want to use this to illustrate what we're doing. So the idea is to sort of unravel this. If we've gone around and around, we want to kind of wind the clock backwards. So when you subtract 360 degrees, you're subtracting a full rotation, so you're definitely going to land in the same spot. And so that's the idea. Well, if we do 900 degrees minus 360 degrees, then that's going to give us, let's see, if we subtract 300, that'd be 600, and there's 60, so this would be 540 degrees. All right, that's still more than 360 degrees. So we can take the same approach. Let's unwind or wind the clock backwards one more time. So subtract 360 degrees again. And when you do that, you get 180 degrees. So that means, and that's why I was saying this picture is not accurate for 900 degrees. Let me get rid of it now. What that tells us, in fact, let me redraw this whole thing. 900 degrees. So kind of, let's break it down. There were two full rotations. 360 degrees, two full rotations that we subtracted, and then there were 180 degrees left over. If you add all this up, you will get 900 degrees. So the way we could illustrate that, so 360 degrees, that's one full rotation. Let me use the blue marker. So if it's standard position, that means that the vertex is at the origin, the initial side is on the positive x-axis. One full rotation gets us here, that's 360 degrees. We would go another full rotation, that lands us here, and then 180 additional degrees. And so we end up with a terminal side on the negative x-axis. This is our 900 degree angle. So now that we know where the terminal side is, we can choose any point on the terminal side and use that, use the coordinates there to generate the values of sine, secant, whatever else. You can choose any point you want on the terminal side other than the origin. So a lot of times it's nice, let's make one of the coordinates 1, or negative 1 actually here. So I'm going to choose the point negative 1, 0. So if x is negative 1, y is 0, r, remember, is the distance to the origins, the distance from that xy, whatever xy point we chose, back to the origin. So in this case, r, that distance would be 1. It's easy to measure since it's right there on the x-axis. R equals 1. We could, by the way, have just as easily chosen negative 2, 0 as our point, and then r would have been 2. So just, you can choose whatever you want. Once you have your values for x, y, and r, then we can crank out the values of these trig functions using the x, y, r definitions of the trig functions. So secant, not secant, I'm going to do sine first. Sine of 900 degrees is equal to, so trig functions at coterminal angles are equal. So since this is coterminal, we found out with 180 degrees, this is equal to sine of 180 degrees. Sine is equal to the ratio y over r. On the terminal side here, y is always 0. For the point we chose, r is 1. Doesn't matter, it's going to be some non-zero number on the bottom. That ratio is equal to 0. So sine of 900 degrees is equal to 0. To find secant of 900 degrees, we need the x, y, r definition for secant. It's the reciprocal of cosine. So if cosine is equal to x over r, then secant is equal to r over x. In this case, r is 1, x is negative 1. And so secant of 900 is equal to negative 1. Last one, cotangent of 900 degrees. So cotangent is the reciprocal of tangent. Tangent is y over x, cotangent is x over y. So in this case, that's negative 1 over 0. Well, division by 0 is undefined. So cotangent of 900 degrees is undefined. These trig functions that have x or y in the denominator are going to be undefined from time to time when either your x coordinate or in this case your y coordinate is equal to 0. I want to stack one more example into this video. So suppose instead of 900 degrees, we had, let's say, negative 630. So one last example in this video. Suppose we're asked to find values for tangent, let's just say the value of tangent, of negative 630 degrees. So if we first want to draw this angle in standard position, well, it's hard to think in terms of negative angles, so what we could do to find a coterminal angle is we can add 360 degrees. You can always either add or subtract 360 degrees and you'll always land at a coterminal angle because you're just going one full trip around the circle. And so you end up right where you started. So we can take this negative 630 degrees and add 360. Although I already know if we add 360 one time, it's still going to be negative, right? So we know we're going to have to add 360 degrees twice. Add 2 rotations to that. And what do we get? 90 degrees. So negative 630 degrees is equivalent to going 2 full rotations, and actually we would be going in the negative direction, which is clockwise. 1 time around, 2 times around. And then, well, that's where it gets a little tricky. Oh wait, it's not quite 2 times around, is it? Because we should land here at the 90 degrees. Because 2 times around would be negative 720. We're 90 degrees short of that. So the terminal side is here on the positive y-axis. So again, we can choose any point we want on the terminal side. Just for something different, I'm going to choose the point 0, negative 5. Or 0, positive 5, I should say. I'm really off my game a bit here in this video. All right, so choose the point 0, 5 on the terminal side. Then r is the distance from that point to the origin. That would be 5 units in this case. So let me label. So for these coordinates, we're going to use x equals 0, y equals 5, r equals 5. Tangent is equal to y over x. So that'll be y over x, 5 over 0, which again is undefined. And I just want to show one more example of how we can add or subtract a full rotation in order to get that coterminal angle where we know, okay, yeah, at 90 degrees, I know what that looks like. That's up here on the positive y-axis. And then we can choose whatever point we want and generate our value of the trig function. That's the way this works overall.